Let's look at solving complex algebraic equations. So these are going to be algebraic equations involving more than one operation. So let's just review order of operations. If we had 3 times 2 plus 4, we would use order of operations, or PEMDAS. Parentheses, exponents, multiplication or division, addition or subtraction. And we would evaluate this. So we just do 3 times 2 is 6 plus 4, and we would get 10. So that's simple order of operations, just evaluating this expression. But when we're actually solving an algebraic equation, we don't have just all numbers. We have variables in it. So we may have something such as 3x plus 4 equals 10. From this example, we would know that x is 2, because 3 times 2 plus 4 is 10. So if it's 3 times x plus 4, x has to be 2. But let's try and solve this algebraically. I'm just going to use a few steps to do this. First, we're just going to simplify both sides of the equation. So left of the equal sign and right of the equal sign, if possible. Okay, then if there's x terms on both sides, I'm going to get all x terms on one side. So get them all on the left or all on the right. Doesn't matter, whichever you prefer. Then after that, we're going to do reverse PEMDAS. So we're going to do order of operations backwards using inverse operations. Because our goal is to isolate x, or the variable. So let's take a look at this. 3x plus 4, there's no simplifying. We can't combine any like terms or anything like that. And 10, of course, that's as simple as we could possibly have it. So that step's done. Okay, now we want to make sure we get all the x terms on one side. It's only one x term, and it's on the left. That's fine. But now we have to do reverse operations, reverse PEMDAS using inverse operations. So again, if this were a number, we would do 3 times that number and then add 4. So the last thing we would do would be to add 4. So going backwards, the first thing we're going to do is subtract 4. So again, it would be 3 times the number plus 4. So first thing we're going to do is subtract the 4. So that's gone. And on the left, we just have 3x. And on the right, 10 minus 4 is 6. Okay, now here we have 3 times x equals 6. So we know to isolate the x, we have to do the inverse of this. This is multiplication. So the inverse would be division. We're going to divide both sides by 3. And we get that x equals 2. Just as we knew from our little example. Alright, so let's try a different example. We have x divided by 4 minus 3 equals 1. So if this were a number, we would do this number divided by 4. Then we would subtract 3 in order to get 1. So the last thing we would do would be subtract 3. So that's the thing we have to take care of first. We have to do the inverse of subtracting 3, which is to add 3, and we do that to both sides. So we just have x divided by 4 on the left equals 4. Okay, now at this point we have x divided by 4, so the inverse of dividing by 4 would be to multiply by 4. So we multiply both sides by 4, left with x equals 4 times 4, which is 16. Okay, now I'm going to do one more example, but I'll show you how to do it 2 different ways. So 5 times x plus 4, or the sum of x and 4, plus 2 is 27. And I'm going to write this twice. Alright, so the first method we'll just do reverse order of operations or reverse PEMDAS. If this were a number, we would have to add 4 to it first. That would be step 1. Step 2 would be to multiply it by 5. And the last step would be to add 2. So because adding 2 is the last step, we're going to do that first. We're going to do the inverse, so we'll subtract 2 from both sides. So on the left we just have 5 times x plus 4, and 27 minus 2 is 25. Okay, at this point we have 5 times x plus 4, so we would add these together, then multiply by 5. So multiplying by 5 would be the last step here, so we have to do the inverse of that and divide by 5 on both sides. So we have x plus 4 equals 25 divided by 5, which is 5. Now you just simply have x plus 4 equals 5. We'll just subtract 4 from both sides. And we end up with x equals 1. Alright, so now that's one method. The other method would be to simplify this as much as we can first. So what I'm going to do is distribute this 5 into here. So 5 times x would be 5x. 5 times 4 is 20. Okay, notice I'm not distributing the 5 to the 2, only to what's in the parentheses. So we just have plus 2 equals 27. Okay, now simplify some more. We have to combine like terms. So the 20 and the 2 combine. So we have 5x plus 22 equals 27. Now at this point, everything is simplified as much as possible. And we have all the x's on one side. So we'll just do inverse operations to do PEMDAS in reverse. So we have 5 times a number. Then we would add 22. So adding 22 would be the last thing we do. So the inverse of that has to be the first thing we do. So subtract 22 from both sides. So on the left we just have 5x. And 27 minus 22 is 5. Okay, now we have 5 times x equals 5. So we have to do the inverse of multiplication, which is division. Divide both sides by 5. Okay, now at this point, don't get into the habit of canceling things out. If you just cancel this out, you might think this is 0. But really, 5 divided by 5, when it cancels out, you're left with 1. Just do 5 divided by 5 is 1. So in both cases, we get x equals 1. So when we're solving algebraic equations, regardless of how complex they are, we're really just going to do order of operations in reverse, and we're going to do our inverse operations to isolate x.